Okay, so I'm going to try to go over this fairly quickly. Um, there might be even two videos to kind of go over this whole assignment. The reason why there's two is because the software that I use is only about 15 minutes long. Because it's only 15 minutes long, then we might have to do two of these just so we make sure we cover everything. So I'll try. Just the good thing about this is if there's something you don't understand, you can always stop it, rewind it, do some things just in case you don't understand what I said. Okay, let's go ahead and get started. So on the first thing it says, how can you find points that are equidistant from endpoints A, B? Okay, this is where we use our compass. Okay, I know you guys love using those things. So basically you'd have a compass and you would start at point A and then you would draw a line above and below the line. Then you go to the other side on B, where you have the compass in the exact same spot, and then you draw lines where it crosses, and then what you do is you connect those intersections with basically a straight edge, and then you end up with something that is equidistant from from A and B. So how can you find points within points? One way you could do this is measure and divide by 2, or using a compass. Using a compass and drawing lines and drawing intersecting arcs. I'm having a hard time spelling right now. Sorry about that. There we go. Intersecting arcs. So then the next question asks, what do you notice about these points with the relationship between A? Well, not only do we have drawing, basically what we have is we create a line that is equidistant from both. So if equidistant, then basically you just created a midpoint. Okay? So you have found a midpoint. Not only have you found a midpoint, but you have also drawn a line that it bisects. So you're bisecting the line. And we've talked about bisecting before, where it'd be angle bisectors, but now we're going into angle bisectors and perpendicular bisectors. Okay, so in this one it says, in the first theorem it says perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, which also means it's a line that not only is it bisect but creates a 90-degree angle, we said it right there, then it is equidistant from the endpoints of the segment. So basically that's what those little marks are there for. It's saying this is going to be equal to this. Okay, those little tick marks saying that x to q is going to be the same as y to q. They're going to be equal to each other. Remember we talked about the word converse before. Okay, remember we talked about the converses in Chuck Taylor's, the logos on the inside where we're flip-flopping it. So that's kind of what the converse of this is. So basically it's saying is if you have equidistant lengths on a vertex or on a segment, then basically you have a perpendicular bisector. Okay, so what this is saying is basically the backwards version of before. If a point is equidistant from the endpoints of the segment, then it is a perpendicular bisector. That means it bisects and creates a 90-degree angle. Okay? Now, if we were using compasses, like we have a little bit before, what you would do here to try to find something that is equidistant is says, where should he park so he could be equidistant between the zoo entrance and the park entrance. Okay, so basically what you would do is you have a segment here, and you would draw your arcs, connect your arc, and keep it going all the way down with a straight edge. And you'll notice right here, if you parked on the street, this is where Mr. should park. Is equidistant here as it is equidistant to the zoo entrance as well. So the park entrance and the zoo entrance are going to be the same distance, so therefore you won't have to walk extra and things like that. Which I know this is something you guys think about when you park somewhere to go in somewhere. Especially if you go to Lowe's or if you go to Home Depot where you have the exit on one side, entrance on the other side, and just something you could use. I personally don't do that. I personally go to where the exit, walk further to go to the entrance, and then when I leave, I go to where my car is. But this is another example of something that you could do. You could go from your entrance. So if you have Lowe's entrance here, you have your exit here. Well, how can I park somewhere that is directly in the middle? Okay, that's something you could do to find where the middle is, what equidistant from the entrance to the exit, or entrance and exit being equidistant from each other. I don't expect you to do that on your everyday basis, but it is just a little neat example that you can think about. All right, for now, skip over this part. It's probably more of an explanation that I probably need to do in person, so just skip over that part. All right, so at the bottom though, this is where we're going to learn to apply. Very, very easy stuff, okay? Once you realize that we have a perpendicular bisector, so we have two equal parts, it says 11 and 11. So now what we have here is we're going to have these two triangles, or these two sides are going to be congruent to each other. So to find the value, so first we can just set them up equal to each other. 6x minus 10 is equal to 3x plus 2. And we can solve. So subtract 3x from both sides. I can learn how to use this pen again. So then we have 3x minus 10 is equal to 2. Add 10 to both sides. Now we have 3x is equal to 12, so x equals 4. Now we're not done yet because it asks for what is AD. Okay, so it wants to know this line right here. Okay, so now we got to take this number and plug it back in. Okay, so once we plug it back in, we know 3, insert our x, plus 2, so we end up with 12. 4 times 3 is 12, plus 2 is equal to 14. So your answer to this question is going to be 14. Now I want you guys to pause the video and try the next two on your own. After you get done looking at it, or after you get done finishing these problems, come back, push play. I'll have the answers, or I'll talk to you and step by step on how to get the answers to this. Hopefully you are checking yourself right now, not just looking at to see how I got to the answer. So you don't have to do the work yourself. You won't get any better at it if you don't do it yourself. Okay, so in this situation, we just set these equal to each other. So we have 5n minus 2 is equal to 2n plus 7. Send it with 3n is equal to 9, n equals 3. So then it's asking for wy, which is this portion here. So then we will recreate and 2n, sorry about that, 2, and then we'll insert 3 plus 7. 2 times 3 is 6, plus 7 is 13. So our answer here is 13. What makes this one a little bit different is looking for OL. OL is this portion right here that I've highlighted. Okay, so based off what we have a triangle, we have this is our perpendicular bisector. So now we know that this here is going to be the same as equidistant as it is for that whole thing. But we don't have the whole thing. We know that the whole thing is 14 over here, so really this whole side is also going to be 14. The issue becomes it's asking for just the navy or the blue highlighted portion. Okay, so because this triangle below it is also a perpendicular bisector, it bisected the line in L. Okay, and NL is equal to JN, and we know that JN is 14. Okay, so NL has to be 14 as well, because it equals the same as JN. Well, because NL, as we said up here, is bisected, that means this 14 is now cut in half. So now OL is 7 because it is the bisected or the halved version of NL. Alright, so in this problem it says consider the two triangles resulted in from drawing a segment from the point on the angle bisector where the inspector stands to each conveyor belt, forming a right angle with the conveyor belt. With the conveyor belt. How are the triangles related? One thing you'll notice is, yes, here's a triangle here, and here is a triangle here. Okay. Well, basically, what this person is doing, his job is basically being on a conveyor belt. He has to be equidistant between both conveyor belts. So basically, they put a piece of tape down to explain from another problem that I decided to skip. But they put a piece of tape down so he can be equidistant between both conveyor belts. So in this particular problem, it's asking you what do you notice about these triangles? Well, both of them have a right angle here and here. Now they both also have an angle that are congruent here. Well, if you remember our congruent triangles before, this line is the same on both triangles. So that line is due to the reflexive property. Okay, so since now we have an angle and an angle and a side. So now we know that these two triangles are going to be congruent because of angle, angle, side. So that's what the relationship, or how these triangles related, they're congruent based off angle, angle, side. Now we're going to have a couple more theorems to talk about. Most of this whole chapter is going to be relationship of triangles. So it says if a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. Then BD is equal to CD. So basically it's saying this is going to be the same as this. So if CD was 4, then that means BD also is going to be 4. And the theorem 5.4 is basically the converse from above. So now it's saying if these are equidistant from each other, equidistant from two sides of an angle, then it is an angle bisector. So basically what it does, it creates an angle bisector, which means those two angles are going to be the same. So if this angle so happen is 27, then because it bisects, creates two equal ones, this is also going to be 27. Okay, we're about to hit that 15-minute mark, so I'm going to close this one up, and you guys apply down below, and I'm going to create a new video. So this would be the first version, the other will be the second version.